Thank you, Miriam, for the short introduction. Pick and place with robot vision. In this video, I will tell you about pick and place in automation. We'll have a look at the components and fields of engineering. Especially, we'll have a look at the vision system. We will see when it's useful to have a 3D vision system or when it's enough to use only 2D data. Then we'll have a look at an example for a bin picking application and see the approach to grasp an object. Last point is you have accepted the challenge of installing a pick and place system in your company, and we will show you the first points of how to getting started. After the video, there is a small Q&A session where you can ask your questions. First, let's start with an example that is not from automation, but from daily life. Imagine that. It's lunchtime and you're sitting in front of the table and you're just about to grasp your fork and start eating. Somehow you know where the fork is and how to move your hand into the right position to grab the fork. Well, what's actually going on now? Your eyes are receiving the light that is emitted from the objects on your table. There might be a glass or the table itself and whatever, but somehow you know this is the fork. Then you know where your hands are and you can grab the fork without making any effort of this. But how do you move your hand towards the object? Your hand is not directly controlled by your muscles. It's the joints and the angle of your joints that define the position of your hand towards the object. Your muscles control the angle of your shoulder, of your elbow, of your wrist, and this way your hand is moved into the right position to grasp at the fork. Well, next thing is you think about the motion your hand approaches the object. If you just run at high speed towards the fork, you just might throw it away from your plate. So you have to reach a certain position that makes you able to grasp at the fork. Next, we go back to pick and place in automation. First question is, why is pick and place used in automation? Now, probably it's a way to save money. But why is this? Well, a robot can work 24 hours a day, each day of the week, without getting tired. And the robot will remain its accuracy once you've set up the system for a good accuracy, then the system will work at this accuracy much more longer than a human can do. Humans are getting tired when repeating the same kind of motion the whole day. Robots are not getting tired, they are not getting bored, and though they can perform repeating tasks a whole day long with same accuracy. And robots can handle difficult objects like heavy weights or hot, radiating, toxic objects that humans wouldn't like to touch at all. So these are the reasons why some tasks are likely to be replaced by robots. Pick and place systems are involving 3 main fields of engineering. Let's have a closer look at these fields. First is you have to locate the objects. Think about the example of the lunch. So you have to figure out where is my fork located. This is job of the vision system. The next is figuring out the angles of your joints. Some robots are equipped with 6 joints, so you have to figure out for each of these joints the correct angle to move the hand into the desired position. This is called kinematics, and it's a separated field of engineering. The next is achieve accurate and smooth motion. This is called motion control. Motion control normally is included in the robot control that comes with your robot. Now we'll have a closer look at the components of these fields of engineering. The central part is the object. You want to handle your object, you want to pick it and you want to place it. So let's look what the vision system does here. The first thing is what you need is a kind of sensor that gives you the possibility to reconstruct the scene, and later you use software, that's the vision software, that is used to extract the needed object from this scene. Of course, your software has to run somehow. This is a computing system, and for most approaches you will need a CAD model from your object that makes it easier to find the needed object within your reconstructed scene. So the vision system's job is to locate the object's position. Then we have the kinematics and the motion control that are engineering fields to figure out the angles of the robot joints and to achieve smooth and accurate motion of the robot towards the object. In this video, we'll focus on the vision system. So I've talked a lot about the location of an object. Now I will tell you a bit more about what is meant with location. It's not only the position somewhere, it's the position and the orientation. In mathematics and mostly in machine vision, there is a phrase called pose, and this pose completely describes the orientation of one coordinate system with respect to another coordinate system. Here our reference system is shown in red. It's called the XYZ coordinate system. In American English sometimes you will hear XYZ, so don't get confused. It both means the same. The green line shows the translation that the new coordinate system is moved, that the origin is moved from the red to the green point. So it's a translation vector to get the new origin of the new coordinate system. And as you see in the image, the new coordinate system is rotated somehow towards the reference coordinate system. And this can be described by 3 consecutive rotations about the 3 coordinate axes. There are lots of descriptions to formulate how the new coordinate system is rotated with respect to the reference system, and you can find lots of information how to convert these to each other. But normally you have 3 angles for the 3 axes that describes the rotation, and you have 3 components for a vector that describes the position of the origin of the new coordinate system. Now, when you're about to design a vision system, you have to look at the complexity of your pose. So if your object is completely defined in its pose, then your vision system doesn't have to do much, and it's a low complex vision system. And if all degrees of freedom are randomly, then your vision system has to do a high complex job, because it has to figure out the pose of the object in all 6 elements. So you have to figure out the transformation and the rotation of the object with respect to your reference coordinate system. This means when moving from low to complex vision systems, the amount of data will increase. The complexness of calculations will increase. This means you have to use a more powerful computing system to achieve the same frame rate as with a low complex vision system. And this, of course, will raise the costs. Here you can see a vision system which works with 2D data. You see the boxes are placed on a conveyor belt, and thus the z-axis of your boxes is known because it's perpendicular to the work plane, which is the conveyor belt. So you only have to figure out the translation of the object's center and its rotation around the object's z-axis. This system can use a 2D sensor in the vision system, and they can achieve a high frame rate in providing object positions. Now, when looking at this, you see the boxes are rotated and their z-axis is not known. And in this case, the vision system has to figure out the 3D position of the object as well. Now you might wonder, why is there only a 2D sensor placed? Because I need 3D data, why only using a 2D sensor? Well, there are some algorithms that are able to detect the 3D pose of an object in a 2D image. Of course, you can use a 3D sensor, which will provide you the whole surface in 3 dimensions. And the advantage of using a 3D sensor is that you also can use the data to inspect the object surface. For example, if you want to find defects or something else. So you have information on the object surface when you use a 3D sensor, which is not as easy when you do 3D detection with 2D sensors. Now, for an example, we want to have a look on a bin picking application. This is one of the high-class applications where your object has all pose, the complete pose is randomly, and the vision system has to detect the object's pose in 6 elements. So three elements for the translation, 3 elements for the rotation. And then this is the prerequisite to grasp the object. You have to figure out its pose. Before you can do this, you start with the hand-eye calibration. And the hand-eye calibration yields the relative position of the robot's hand and the camera. So the robot has to know where is the object and where do I have to move my hand to grasp the object. And the camera provides 3D data in the camera coordinate system. To put this together, you need a hand-eye calibration, and then the robot knows what the camera sees. So our friend is now happy to have lunch, and he knows I can move my hand to the position which is figured out by the vision system, but still it's not clear how to move the hand. So you can move it like this or like that or like this. You are in the same position, but it's a different it's a different pose of the robot. So how can you figure out how to pose the robot hand towards the object to be able to grasp it? This is done by defining grasping points on the object. So here you can see, in this example we did it by using Mikado. It's a software that helps for such tasks with simulation tools. There are other softwares as well, but so for our robot at IDS we are using Mikado, and from this system I took these images. Here you can move the object's CAD model and the gripper's CAD model and place them relative to each other to define the gripping positions. So let me show here with this cup an example. So you want to grasp this cup and you want to tell the software, how can I do it? You can grasp it from the inner diameter, or you can grasp it from the outer diameter. If you grasp from the inner diameter, you can rotate the cup in 360 degrees. It doesn't matter. If you want to grasp it on the outside, you have to take care for the handle here that your robot doesn't have a collision with the handle. So that the robot knows how to approach to the object to be able to grasp it, he has to know where am I allowed to grasp the object. So if he's not allowed to grasp here on the handle and the cup is placed in this direction towards the robot, so he couldn't move here, he has to approach the object in another direction. And this has to be known to finding out the position where the robot moves to before he grasps the object. The last thing is not directly related to vision systems, but I will mention it here as well because this is also needed for defining the position that the robot uses for grasping the object. So you have to define the cell's geometry, that the robot doesn't collide with anything inside the cell or with the cell itself. So the robot has a camera on its hand, there are cables, there are boxes inside the cell, and all this has to be considered when figuring out how to move the robot to grasp the object. And these 3 steps, the hand-eye calibration, defining of the grasp positions, and describing the cell geometry, are things you have to do only once before starting the system. And so it's saved and stored in software, and then when running the application, this data is used. Now we have a look at the running application. So what's the job of the vision system in the running application? First, you acquire the 3D scene and reconstruct it. Then you have all what is visible for the sensor in 3D data. And then you have to find out where is the object inside my scene. So best thing is you throw away most parts of the scene in 3D data that are not part of the objects. And then you have, next step would be the 3D matching to find out the object's position. If you have found different objects, then you have to decide which one of the objects is the one I want to grasp. So maybe you want to consider which one is placed on the top level, or which is one where the robot can achieve an easy movement to grasp it. So there are different approaches that you have to consider when deciding which objects you want to grasp from the maybe your algorithm found 10 objects, and you have to tell the robot which to grab. And if you know the position and the object which you want to grasp next, then it's the kinematics that is used to calculate how to move the robot to get its hand into the needed position. And to avoid collisions while moving to this position. And if you know all the points where your robot is allowed to move along its way, then it's the motion control that calculates the needed power for the motors to move the robot in the right way. Now we have a small example that shows a running system, just what I described. It's a bin picking application, and we see here these small parts that are in the video shown for defining the grasp positions. So now you can see what the robot does with this information. So you see the robot isn't only gripping aligned with the Z-axis, Z-axis, he is also allowed to grasp in an angle. And another thing that is important when doing a bin picking application, of course, you want the robot to completely get the box empty. And depending on the sensor and the possibility of 3D matching, maybe the parts on the ground are difficult to match, or the parts in the edges are difficult to be reconstructed in the 3D data. Now let's summarize and see how you can master your pick-and-place application. First, you have to look at your objects and figure out what is needed from the vision system. Which information should your vision system provide to the robot? So you have the information of how many degrees of freedom does your object have? How many degrees of freedom do you have to figure out? Are you interested in the surface of the object? So maybe you want to do some defect detection or things like this. Yeah. Then, depending on the results of your investigations, you find the vision system that suits your application. As we have seen, there are different vision systems. So maybe you can use a 2D system. Maybe you can use a 2D sensor together with an algorithm like shape-based matching, which provides 3D data from a 2D sensor. Or you go by using a sensor that already provides 3D data of your scene. Now we are having new approaches for vision systems with artificial intelligence. So maybe you can try this or a combination of both. And this is a field of engineering that's developing very fastly, and so I can only recommend you stay tuned and have a look on the information channels for what's new in 3D vision, robot vision, and matching algorithms. And yeah, then you can try a simulation tool. So you capture your scene, you have 3D data of your reconstructed scene, and then you can use simulations to find out how good is your algorithm to locate the objects in your scene. To set up the application, you can do this alone, or you can ask for a partner. There are several companies that are dealing with robot applications that would be helpful if you have less knowledge in robotics, in vision system in your company, and want to set up your pick-and-place system. So I'm sure you will find your way to set up your pick-and-place application for your objects. And thank you for watching.